So far, we have written all our code in one file, app.py. But that's not how we build real programs, because a real program can contain tens of thousands of lines of code. We don't want to write all that code in one file. That is like going to a supermarket without any sections. All products are in one place. Finding a product in a supermarket like that is really hard, right? That's why in supermarkets we have various aisles or sections or departments. We have the same concept in programming. So as our program grows, we should split our code across multiple files. We refer to each file a module. So a module is a file that contains some Python code. Now here's a question. How do we decide what functions or what classes we should put in what modules? Once again, let's go back to our supermarket example. In a supermarket, each section contains highly related products. So when you go to the fruit section, you only see fruits. You don't see cleaning products there, right? By the same token, a module should contain highly related objects. These objects can be functions, classes, variables, and so on. So here, as an example, I have defined two functions. These functions have no implementation, but they are both highly related to the concept of sales. We have calculate tax and calculate shipping. So let's go ahead and put these functions in a separate module called sales. Here in the project folder, I'm going to add a new file and call it sales.py. This is our sales module. Note that in terms of naming convention, just like variables and functions, we use all lowercase letters, and if you have multiple words, we separate them using an underscore. Now, back to app.py. Let's get all this code and move it to sales module. Okay, now back to the app module. We need to import one or two functions from our sales module. There are a couple of different ways to achieve this. You have seen one way before. So we start with from, then we add the name of our module, which is sales. Note that it's not sales.py, it's only the name of the file. Okay, so from sales, import. Now, if you press Control and space here, you can see all the objects defined in this module. Currently, we have these two functions, as well as a bunch of variables that Python automatically creates. We'll look at these later. So let's say we want to import the calculate shipping function. There you go. Now we can call this function just like a function that we have defined in our app module. So calculate shipping, as simple as that. Now, if you want to import multiple objects from a module, you can separate them using a comma. So here we can also import calculate tax and then call it here. Now, there are some tutorials out there that teach you a shortcut to import multiple objects using an asterisk. While this makes your code shorter, it's actually a bad practice, because in that module, you could have several different functions or variables, and if you blindly import them into the current module, some of those objects may overwrite the objects with the same name in the current module. So don't import all objects like this. Only import the stuff that you need. So let's put calculate shipping and calculate tax here. There is also another way to import a module. Instead of starting with from, we start with import, and then we add the name of the module. Now, in this module, we have an object called sales, and we can use the dot operator to access its members. So our calculate shipping function is now a method in this object, and we call it like this. So basically, you can either import the entire module as an object, or you can import specific objects from that module. What approach you choose is purely your personal preference. There is no right or wrong here. There is not even a performance difference, because whenever we want to import one object from a module, that entire module needs to be loaded. Now we can pick one object or every object in that module. So these are the files or modules we currently have in this folder. We have app.py, which is our main module or the entry point to our program, as well as the sales module. Now, when I run this program, you will see a new folder here. So Python app.py. There you go. We have this new folder, PyCache, and in this folder, we have the compiled version of the modules that we import into our program. So currently we have the compiled version of the sales module. The reason Python stores these compiled files in this folder is to speed up module loading. So next time we run our program, Python will look at the content of this folder, and if we do have the compiled version of the sales module, Python will simply load that compiled version. So it will skip that compilation step, and this will result in faster loading of the sales module. Note that it only speeds up the loading of this module, not the actual performance of the application. Now, how does Python know if this compiled version is up to date with the latest code in the sales module? Well, it basically checks the date time of these two files, the compiled version as well as the source code. If the date time of this source file is newer, it realizes that our source code is changed, so it will recompile it and store it in this PyCache folder. So that's the basic idea. Now, this CPython 37 you see in the file name here represents the Python implementation used to compile this file. So we have compiled this file using CPython version 3.7. In this file, we have Python bytecode. Let me quickly show you. So when we click this, by default, VS Code doesn't show the content of this file because it's binary. But if we click this link here, we can see the Python bytecode representation of our sales module. Now back to this PyCache folder. Note that we don't have the compiled version of the app module because Python always recompiles the module that we load directly from the command line. So in this demo, I passed app.py as the entry point to Python, and that's the reason Python didn't cache the compiled version of this module. So here in app.py, I'm currently importing the sales module. When Python sees this, it will look for a file called sales.py in the current directory. If it doesn't find this file, it will look in a bunch of predefined directories that come with Python installation. Let me show you. So we have a built-in module called path. Let's import that. In this module, we have a variable, path, which returns the list of directories that Python will look at to find a module. Let's print this on the terminal. So as you see, we get an array of strings. The first element in this array represents the current folder. So on my machine, that is Mashfaq Hamadani /Dropbox, courses, Python, blah, blah, blah. On your machine, it's going to be different. After that, we have library, frameworks, Python framework version 3.7, da, 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 da. Again, this is going to be different on your machine depending on your operating system. I'm using Mac, so this is the address of Python installation on Mac OS. On Windows, you're probably going to get something like C drive, /program files, Python, blah, blah, blah. So when Python sees an import statement, it will search all these directories to find this module. As soon as it finds the module, the search stops there. Now, you might be curious how we can import a module from a subdirectory. Well, to do that, we need to look at packages, and that's the topic for the next lecture. Currently, all our files or modules are in this folder, but as our application grows, we probably want to organize these files into subdirectories. Otherwise, we'll end up with hundreds or even thousands of Python files or Python modules in one folder. That is not good. So in this demo, I want to move this sales module to a subdirectory called e-commerce. So I'm going to add a new subdirectory, e-commerce, and then drag and drop this module right here. Now back to app.py, you can see we have a red underline here because Python cannot find the sales module. To fix this issue, we should come back to our e-commerce folder and add a new file called _init_.py. When we add this file here, Python would treat the e-commerce folder as a package. So a package is a container for one or more modules. In file system terms, a package is mapped to a directory and a module is mapped to a file. So now we can go back to app.py and prefix the name of this module with the name of its package. That is e-commerce.sales. Save the changes. The error is gone. Now to use any of the objects in the sales module, we need to prefix them with the name of their package and module. So e-commerce.sales.calculate tax. Obviously, this is going to make our code a little bit noisy because every time we want to use one of the objects in the sales module, we'll have to type e-commerce.sales. That is tedious. A better approach is to use the from statement. So we change this to from, e-commerce.sales import calculate tax. Now we can simply call this function like a function defined in app module. That is better. But what if we want to use multiple objects in the sales module? Well, we can list them all here. But if that ends up being too noisy, we can take a different approach. So we can type from e-commerce import sales. So we're importing the sales module as an object, and then we can use the dot operator to access all the members of this module. As your programs grow, you may want to break down a package into sub-packages. For example, let's imagine our e-commerce package has grown a lot. We have so many files and modules here. So we decide to break this package into a few sub-packages. So I'm going to add a new folder here, call it shopping, and then move the sales module in this folder. So on the top, we have the e-commerce package, and under that, we have the shopping package. Now, currently, shopping is not a package because in this folder, we don't have the init file. So let's add a new file, _init _.py. Now back to app.py. Once again, Python cannot find our sales module. So to fix this issue, we need to add the name of our new sub package here. So e-commerce.shopping. There are times that you want to import modules from sibling packages. For example, here in our e-commerce package, I have added a new sub package, customer. In this package, we have this contact module for contacting our customers. Now, let's say in our sales module, we want to use the contact module in the customer package. Let me show you how to do this. So we open this. To import a module from another package, we can use an absolute or relative import statement. So here's an absolute import. From our top level package is e-commerce. So we start there. Then we go to the customer sub package. And now we import the contact module. So this contact object has a method we can use anywhere in this module. So this is the absolute import. We can also use a relative import. So from dot, this represents the current package. Dot takes us one level up. So now we're at the e-commerce package level. In this package, we have two sub-packages, customer and shopping. So we can go to the customer sub-package and then import the contact module. As a best practice, prefer to use absolute imports, and that's what PEP 8 also recommends. But if your absolute import gets really verbose, like A.B.C.D.E, then you might be able to simplify the import statement by using a relative import. In this lecture, we're going to look at a powerful built-in function called dir. With this function, we can get the list of attributes and methods defined in an object. So in this example, we're importing the sales module. As you learned earlier, now sales is an object, so we can use the dot operator to access all the methods and attributes defined in this object. Now, as you work on large projects, there are times that things don't work as you expect, so you can use the dir function for debugging. Let me show you. So let's print dir of sales. When we run this program, we get an array of strings. In this array, we have all the attributes and methods defined in an object. So as you see in our sales module, we have these two functions, calculate shipping and tax, as well as these magic attributes that are automatically created for us. Let's take a look at a few of these. So I'm going to comment out this line and print sales.name. That returns the name of our module. We can also get the name of the package, as well as the file name, as well as the address of its file. So let's run this program. So here's the name of our module. As you can see, it's fully qualified with the name of its packages. After that, we have the name of our package. So the sales module is defined in e-commerce.shopping package. And below that, we have the path to this file on file system. Here in our sales module, currently we have defined two functions, but we can also write any statements, and these statements will be executed the first time this module is loaded. So if we import this module in a few different modules in our program, Python will load this module only once and then cache it in memory. So the statements that we write here will be executed once. As an example, let's print something like sales initialized. Now let's go back to our app module. To quickly look up a file, you can press Command and P on Mac or Control and P on Windows. Here we can type app.py. There we are. Now when we run this program, you can see our sales module is initialized. Using the same technique, we can write the initialization code for our packages. So once again, Command and P on Mac or Control and P on Windows. We can go to the init file for the e-commerce package and print e-commerce initialized. Now let's go to our app module, run the program again. As you see, first our e-commerce package and then the sales module are initialized. Now let's take this to the next level. Let's go to our sales module and print the name of this module. So as you learned in the last lecture, every module has a built-in name attribute that is automatically created for us. So save the changes, back to app module. Let's run our program. So as you see, here's the name of our module, that is ecommerce.shopping.sales. However, if we go to sales.py and run this file, the name of our module is changed to main. So the name of the module that starts our program is always main. Now we can do something interesting. Let me show you. So I'm going to delete this initialization code on the top. After we define these functions, I'm going to write some code like this. If name equals main with 2 underscores, I'm going to print sales started and then call the calculate tax function. With this code, we can make this file usable as a script as well as a reusable module that we can import into another module. So if we run this file directly, the name of this module will be main, and here we can have any initialization code, or we can call one of the existing functions in this module. However, if we import this module into another module, this code will not be executed because at that point, the name of this module will no longer be main. It will be ecommerce.shopping.sales.